In a daring revelation that has sent ripples through the scientific community, NASA has announced the discovery of a world unlike anything previously studied. A planet, or more accurately, a dwarf planet, whose characteristics challenge everything we thought we knew about our solar system. It isn't just the size or its orbit that makes it extraordinary. The true shock comes from its light, shimmering, reflective, and unlike anything observed on typical asteroids or rocky bodies. These are not mere glints of sunlight off ice or rock. The light appears structured, organized, deliberate. Almost as if someone, or something, turned it on. For decades, humans have wondered whether life exists elsewhere. But what if life isn't just possible? What if life has left signatures, messages, beacons, or simply hints of activity? And what if those signs have been right in our cosmic backyard, unnoticed for centuries? This question now drives every observation, every analysis, every debate surrounding this mysterious body, Ceres. To understand the significance of this discovery, we must go back to 2007, when NASA launched the Dawn spacecraft, an engineering marvel equipped with ion propulsion engines. Unlike conventional chemical rockets, Dawn's engines provided a gentle, continuous thrust that allowed the spacecraft to perform precise maneuvers impossible with traditional propulsion. Its mission began with Vesta, the second largest object in the asteroid belt, a rocky relic from the solar system's formation. Dawn mapped Vesta's towering mountains, deep craters, and rugged terrain, sending back data that transformed our understanding of early planetary processes. Yet scientists knew that Vesta was only the prelude. The real intrigue lay farther afield, at Ceres, a dwarf planet shrouded in mystery for over 2 centuries. Discovered in 1801 by Giuseppe Piazzi, Ceres is the largest object in the asteroid belt, measuring approximately 950 kilometers across. Once classified as an asteroid, then reclassified as a dwarf planet, Ceres occupies a unique position, too small to be considered a planet in the traditional sense, yet massive enough to have complex geology, potential water, and perhaps even hidden life. When Dawn arrived in early 2015, it provided humanity with the first close-up views of this enigmatic world. Initial images revealed craters and shadows consistent with a long history of collisions. But then came the first anomaly, brilliant, reflective spots scattered across the surface, especially concentrated in a crater known as a crater. These were not subtle glimmers, they were bright, clean, almost unnaturally reflective, catching sunlight and standing out against the dark, rocky terrain. The scientific community was captivated. Early speculation considered natural causes, ice deposits, reflective minerals, or ancient frost. But high-resolution imaging revealed the brightest spots were composed of sodium carbonate salts, the residue left when liquid brine evaporates. This discovery was revolutionary. It suggested that Ceres once harbored liquid water, and possibly still does. The implications were staggering. A dwarf planet with active geology, subsurface brines, and the potential for life. Even stranger were the faint, periodic hazes observed above some of the bright spots. Dawn recorded these as subtle plumes, appearing at dawn and fading with sunlight. The phenomenon resembled cryovolcanism, where icy volcanoes erupt briny water instead of molten rock. This was not a frozen, dead world. Ceres was alive, breathing, and geologically active. The presence of water alone transformed Ceres from a minor curiosity into a prime candidate for astrobiological research. But it was the behavior of the bright spots that sparked the boldest theories. Some spots pulsed subtly, varying in intensity over hours, even in the absence of sunlight. Could these fluctuations be natural chemical reactions? Or could they be something else entirely, signals, a pattern, a beacon? Ceres' composition only deepened the mystery. Its surface is a mixture of rock, ice, and hydrated minerals like clays and carbonates, giving it a porous, less dense structure than typical asteroids. Beneath this crust lies a muddy mantle and a core rich in water ice, possibly accounting for nearly half of the planet's volume. This internal structure implies Ceres may have hosted liquid water long after its formation, warmed by radioactive decay in its early history. The discovery of ammonia clays suggests it may have formed in a colder region of the solar system and migrated inward, a journey that preserved the chemical building blocks for life. Cryovolcanism on Ceres offers another tantalizing clue. Unlike volcanic eruptions on Earth, cryovolcanoes expel briny water, ammonia, or methane. As the brine reaches the vacuum of space, it sublimates, leaving behind reflective salt deposits, the very spots observed by dawn. The most famous, inside a Cater crater, shines so brightly that it could be visible from Earth with advanced telescopes. But the real surprise is that these spots appear dynamic, sometimes glowing in patterns, suggesting that cryovolcanism on Ceres is not just a relic of the past, but potentially ongoing. Even the thermal maps Dawn captured are extraordinary. Certain regions radiate heat inconsistent with passive solar warming, indicating active subsurface processes. Some bright spots emit faint infrared signals that cannot yet be explained fully, hinting at subterranean movement of brine or chemical energy. These findings challenge the assumption that small solar system bodies are geologically inert, painting Ceres as a complex, evolving world. As Dawn's mission progressed, scientists began noticing subtle patterns in the distribution of bright spots. Clusters appeared in geometric arrangements, triangles, clusters aligned with crater rims, and streaks that suggested fluid movement beneath the crust. Could it be purely geological, or might intelligence, deliberate or incidental, play a role? While speculation remains controversial, the patterns hint at a world capable of surprisingness yet again. Even now, years later, the questions remain. Are these lights merely chemical reactions, the product of cryovolcanism and briny water? Or are they messages in the dark, signals waiting for an observer advanced enough to detect them? Is it possible that Ceres, with its water-rich interior and dynamic surface, hosts microbial life, or even life that has evolved complex chemical networks beyond our current understanding? Ceres has become more than a dwarf planet. It is a gateway into the mysteries of the early solar system, a laboratory for studying water in small bodies, and perhaps a hint that life or prebiotic chemistry exists in places we once thought uninhabitable. It challenges our assumptions, demands our curiosity, and reminds us that the solar system is far more alive than we ever imagined. And so the question that lingers, the one that drives both awe and fear, remains unanswered. Are these reflective spots and subtle plumes simply geological phenomena, or are they something far more extraordinary, something that hints at life or intelligence waiting quietly beneath the icy crust? The Dawn spacecraft continues to drift in orbit, its sensors capturing light, heat, and motion, peeling back layers of a world that refuses to be understood in a single glance. Every image, every data point, every anomaly is a reminder that the universe is stranger, deeper, and more mysterious than we ever thought possible. So, what do you think? Are the bright spots on Ceres just salts and ice, or are they the first signs of something alive, deliberate, waiting beneath the frozen surface? Comment below, share your theories, and join the conversation. And if this story sparked your imagination, make sure to like this video, subscribe, and turn on notifications. Because as the Dawn spacecraft and future missions continue to explore, the mysteries of Ceres, and perhaps life itself, are only beginning to reveal themselves. The universe is whispering. Will we be listening?